In this video, we are going to see chapter number 1, number systems, section 1.3, how to locate root 2 on the number line. So we are going to discuss how to locate root 2 on the number line. So till now, we have located all the natural numbers, all the whole numbers, all the integers, all the rational numbers on a number line. But in the previous video, we saw that irrational numbers also exist, and we want to find out how to locate irrational numbers on the number line. So first, we are going to start with a simple example of root 2, how to locate root 2 on the number line. Now, before we start with the actual problem, one important property of circle is something which we need to discuss. So in a circle, let's assume this is my circle, and we have the center. Okay, let me zoom in. We have this as a center of a circle. Okay, let's call it C. C is the center of a circle. Now for a circle, this is one radius. Okay, let's call it R1. This is one radius, let's call it R2. This is one radius, let's call it R3. This is one radius, let's call it R4. This is one radius, let's call it R5. Okay, in this way we have different radiuses. So we know what is the definition of a radius. A radius is a line from the center of the circle to the surface of the circle. From the center of the circle to the surface of the circle. So in this way we can have infinite number of radiuses for a given circle. So the property is that we must be aware that in a circle, all radius have equal length. Okay, all the radiuses have equal length for any given circle. Okay, so therefore here R1 is equal to R2 is equal to R3 is equal to R4, and that is equal to R5. Okay, from the center you draw any line to the surface of the circle, their length is going to be the same. So this is an important property of any circle. Okay, now this property we are going to use to locate root 2 on the number line. How? Let's see. So let's first construct a simple number line. Okay, so let's say we have here 0. Okay, we have here 1, and we have here 2. So this is my number line. Now I'm going to do some additional constructions in order to locate root 2. So first of all, this is of length 1. Okay, so I'm going to draw another line of length 1 perpendicular at this point. Okay, so first let me give names to these points. So let's call this A, let's call this B, let's call this C. Okay, so AB is of length, the line AB is of length 1. I'm going to construct another line, let's say BQ, which will be also of length 1. So that is an additional construction I'm doing. So let's do it. So I have here, yes, this line, and let's call this point as Q. Okay, let's call this point as Q. Yeah, so now we have A, we have B, and we have Q, and this is a right angle triangle. So let me mark here, this is right angle triangle, and let me try to construct a hypotenuse of this right angle triangle. So we have triangle. So let me write it down. We have triangle ABQ as a right angled triangle. Okay, and we all know that AB is equal to BQ, because that is the construction that we have done, that is equal to 1. They are of length 1. So the unit doesn't matter. You can write here 1 centimeter, or you can write here 1 meter, or you can write here 1 millimeter. It doesn't matter. So just for the sake of easy understanding, we'll assume it's 1 centimeter. So let me just write here 1 centimeter. Now using the Pythagoras theorem, Pythagoras theorem, we can find the length of AQ. Okay, we can find the length of AQ. How is that? So let me zoom out. Yes, so using the Pythagoras theorem, we have AQ square as equal to AB square plus BQ square, okay, and that is equal to 1 square plus 1 square, and that is equal to 2. So AQ square is equal to 2, and therefore AQ is equal to root of 2. Okay. So length of AQ is equal to root 2. Length of AB and BQ is 1 centimeter. So length of AQ will be under root of 2 centimeter. So let's come here and make a note of that. Okay. So this is of length under root of 2. I'm going to mark it like this. This is of length under root of 2. So thus we have got a line AQ of length under root 2. Now this number under root of 2, we have to mark somewhere on the number line. We have to locate on the number line. It's an irrational number as we saw in the previous video. Now how to locate root 2 on the number line? So we are going to do an additional construction. Now we are going to assume that this point A is the center of my circle. Okay, and this point Q lies on the circumference of the circle, exactly like this scenario that we saw here. So here this was a C was the center of the circle. Let's assume here A is the center of a circle and Q is some point on the surface of the circle. So let me use this. Okay, let's say this is some point Q, and in fact let me rename this. Let's call this as A. Okay, so this is my point A and this is Q. This is Q on the surface of circle, and imagine a big circle here with A as the center of the circle. Okay, imagine a circle here. Once again, imagine a circle here with Q as point on the circle. So now what I'm going to do, I'm going to use my compass, assume A as the center of the circle, and extend this and draw this circle from Q till it intersects the number line. Okay, so if I draw a circle, if I construct an arc till it intersects a number line, I will get a point where it intersects a number line. Let's call that point as P. Okay, so I'm going to mark here also. Let's call this point as P. So as we saw in this diagram, that AQ R1 is equal to AP, which is R2. Okay, R1 is equal to R2. So AQ is equal to AP. Similarly, in this case, AQ, which is root of 2, will be equal to AP, which will be also root of 2. And thus, we have located root of 2, successfully located root of 2 on this number line. So AP will be of length root 2. So I'm going to quickly write down the additional thing that we have done, so that you understand that what has happened here. Here basically we have constructed the circle. We have constructed a circle with A as the center and Q as the radius. Okay. So using a compass, with center A and radius AQ. Okay, draw an arc intersecting the number line. You have to draw an arc intersecting the number line. Okay, and by doing this, we find out the point P. We find out this point P, and AP is equal to AQ, but AQ is root 2. We have found that using a Pythagoras theorem here. AQ is equal to root 2, and thus we find AP as equal to root 2. So I'll just write it here. Therefore, AP is equal to root 2. It is of length root 2. And thus, we have very successfully located root 2 on the number line. So this is the point which is of length root 2. So I'm going to in fact write it down. Yes, this will be, so the way, okay. So the way we have this point 0, this point 1, this point 2, this point is where our root 2 exists. So this is root 2 on the number line.